Hello, good morning or good evening or anong oras mo kayo nanonood. So this problem is request from a student. Di ko lang alam kung anong school. Okay. So we have a frame dito no. So by the way, this is point um, point A, B, C, D, and E. Okay. And then we have a hinge dito or pin. Okay. So this is statically determinate frame. Okay, so we're required to determine all reactions, okay, and draw shear, bending, and axial diagrams given yung loadings natin na 1.2 nung dead loads. Okay, W1 is 1.2 ng 12, 1.2 ng 36. So we have 14.4 kilonewton and 43.2 kilonewton. Okay. So, unahin natin of course yung reactions. So, una natin gagawin is to consider yung so let's consider whole structure. Okay. Pero before tayo mag-proceed dito, um, i-illustrate muna natin dito sa figure natin no, yung direction, yung assumed direction ng mga magiging forces. So, unahin na natin yung okay. So, obviously, yung reaction natin sa A and E, both going upwards. So, malaki. So, let's say this is R, A, Y. Then, meron tayong reaction dito. R, E, Y. Okay, and then, merong, W1 na tumutulak dito sa structure natin papunta dito sa kanan. So, pwede nating assume na yung reactions natin sa A and E are opposing yung W1 natin. So, assume natin na yung direction ng reaction sa E and A are both going to the left. So, assumption lang muna. So, this is RAX. This is REX. So, ngayon, if baliktad yung assumption natin, then yung makukuha nating value nung reaction will be negative. Okay? So, again, yung pag nag-negative, meaning baliktad yung assumed direction natin. So, although kasi meron tayong W1 na tumutulak pa kanan, okay, pero meron din tayong W2 na tumutulak dito sa let's say rafter natin no, na pababa. So, pwede siyang mag-cause or nabumuka ito, parang itong dalawang rafter na to, nabumuka siya sa direction na yon. So, pwede pa rin naman, may possibility na magkaroon pa rin tayo ng reaction towards this direction. No? So, anyway, we will find out later kung ano talaga yung direction ng mga reaction. So, yung W2 natin na ganito, so, hindi siya naka-apply directly do sa top chord no, do sa illustration natin or dito sa rafter. So, ang ibig sabihin yun is, well, yung ganyan loading kasi more on live load siya ina-apply. Okay? So, ina-apply natin yung, although dito kasi W2, pwede rin siya sa dead load. But, again, yung ganyang illustration ng loading means na yung nilagyan natin ng load is yung horizontal projection nung area natin. Okay? Or in this case, yung member. Okay, so, pag live load, ganun na ang ginagawa natin. But anyway, again, in-apply dito sa dead load natin yung ganitong loading. So, meaning, yung W2 natin is, by the way, all are in kilonewton per meter dahil uniformly distributed load. Okay. So, yung ganitong load is naka-apply doon sa horizontal projection, which is yung 6 meters span. Although alam natin yung span nitong rough turn natin is longer than 6 meters. Pero ang applyan natin ng W2 is yung horizontal projection lang, which is 6 meter na span. Okay. So, meron na tayong assumed direction. Okay, so, una natin gagawin, so meron tayong 4 na unknowns. 1, 2, 3, 4. So, kailangan natin mag-eliminate nung mga unknowns natin para mas maging madali yung ating computation. So, we can consider getting the summation of moment at point E. Okay? So, kung magmo-moment tayo dito sa point E, so yung REX and REY are both passing through point E. So, wala tayong moment dyan. So, pwede natin disregard yung dalawang forces na to. So, ganun din yung RAX natin. So, nakatapat naman yan dito sa may point E. Okay? Then, RAX will cause no moment about point E. So, yung unknown na lang natin will be yung RAY. So, let's consider course summation of moment about E shall be equal to 0 and taking clockwise as positive. So, pwede tayong kung anong mas prefer natin, kung clockwise positive or counterclockwise negative. So, same lang naman yung magiging output natin. So, RAY, moment arm natin is 12 meters. Okay. Then, itong W1 natin, so ito yung resultant ng W1. Okay, so that will produce clockwise moment then. And then W1 natin, so ito yung value, 14.4. So, plus, dahil clockwise din siya, 14.4 kilonewton per meter multiplied by span na 5 meters. Okay, so ito 5 meters. Then, yung moment arm natin is 2.5. So, kalahati ng 5 meters. 2.5 meters. Okay, then ito namang W2. So, yung resultant ng W2 is, of course, nasa gitna din niya. So, acting dito sa may point C or sa gitna ng structure natin. So, this will cause a counterclockwise moment. So, magma-minus tayo ngayon. Okay, so yung W2 natin is 43.2 kilonewton per meter. Then, yung length natin is 12 meters. Then, moment arm. So, again, yung resultant is yung nandito sa gitna. Okay, so that is 6 meters. So, yan lang lahat yung mga forces na magkakause ng moment about point E. But, since point E is pin support, ganoon din sa point A. So, wala tayong moment doon sa dalawang points na yun. Then, this will be equal to 0. Kasi nga, pin support tayo sa point E. Okay, so, itong mga to is itatranspose natin sa kabila. Okay, itatranspose natin yan dito. Then, di-divide natin ng 12 meters. Okay. So, sabihin, magiging positive to pag na-transpose. Ito naman is magiging negative. So, i-solve natin yung value ng RAY. So, unahin ko yung positive, yung 43.2 kapag na-transpose na siya. No? Times 12 times 6. Then, minus natin yung 14.4 times 5 times 2.5. Okay? And then, i-divide natin ngayon yan ng 12 meters. Okay. So, we have RAY equal to 244.2 kilonewton. Bakit siya nawala? Wala nakasulat dito. Ito ko lang. This is RAY times 12. So 12 meters. Okay, so meron na tayong RAY. So next, pwede tayong mag-summation ng sa construction pa rin, no? Summation naman ng forces about Y or along Y-axis. Okay? So para naman makuha natin yung value ng REY. So if we take summation of forces vertical or along Y, so since that we are in equilibrium, so this is equal to 0. Okay, then ano mga forces yung vertical? So RAY, which is 244.2, REY, so assume natin na pataas, most likely pataas dahil puro about A clockwise ng W2 about A, then ito lang yung kontra ngayon RAY, nagka-counterclockwise. Okay, so again RAY and yung W2 natin. Okay, so sila yung mga forces along the vertical. So RAY is 244.2 kilonewton. Okay, so may value na ito, no? 244.2 kilonewton. Okay, so plus, unahin na natin yung REY. And then, i-minus natin dahil pababa yung W2, which is equal to 43.2 kilonewton per meter multiplied by length or span 12 meters. So, cancel pa rin yung meter natin. And this will be equal to 0. So, solve natin yung REY. Okay, so 244.2. So actually mana to, no? Ita-transpose natin yung 43.2 sa kabila, magiging positive, then 244.2 pag transpose sa kabila magiging negative. So nahin ko na yung 43.2 kilonewton per meter times 12, then minus natin kapag na-transpose yung 244.2 kilonewton. So makuha natin yung so makuha natin yung REY. Okay. So we have 274.2 kilometer. So i-check natin yung solution natin using StatPro. Hindi ko na papakita kung paano ko ginawa yung nasa StatPro. Pero kung gusto nyo lang, so pwede ko rin naman gawin sometime. Okay. So next, yung reaction along X. Okay. So, pwede ba natin i-assume na yung W1 kasi summation ng forces along X-axis, if we consider this X, yung horizontal, pwede ba natin i-assume na W1 is madidistribute equally among A and E, RAX and REX. So, hindi natin pwedeng i-assume na ganun, no? Okay. Kasi meron pa tayong iba pang mga forces. So, meron tayong downward force na, again, focus na parang bubuka yung, kung wala yung support, parang bubuka tong dalawang natin, yung pinakapaa ng frame natin kung wala siyang support dito sa A and E. Okay, so paano natin makukuha yung RAX and REX? REX. O, paano? Bigyan ko kaya ang konting time para mag-isip. Okay. Kasi nag-summation na tayo ng forces along X. So, W1 minus RAX minus REX should be equal to 0. Kaya lang, dalawa yung unknowns natin. Okay. So, kung gagawin natin ngayon is i-consider lang natin tong kalahati. Okay? So, i-consider natin yung kalahati ng ika-copy ko muna to kasi kailangan ko to sa baba. So, consider lang natin yung kalahati ng ating truss. Okay. So, bubura yung calcium. Disregard muna natin to. So, i-consider natin yung kalahati. Okay. So, again, this is point A, B, and C. So, ano ulit yung mga forces natin. So, pag inalis natin ngayon to, so, merong tayo kanina na RAY na equal to 44.2 kilonewton. Then, meron tayong uniformly distributed load dito sa gilid. W1. Okay. Then, meron din tayo force yung again, ang unang assumption natin papunta rito sa left side yung RAX. So, wala muna tong CDE. So, dito lang muna tayo sa ABC. Okay, so since this is spin, so wala tayong moment dyan. So, if we sum up moment about point C, alam natin na equal to 0 dahil nga nakapin tayo. So, ano lang yung unknown? So, ito lang, RAX. So, by the way, meron pa nga pala tayo dito load na kalahati dito sa ano natin. Okay, so hirap talaga mag-drawing sa drawing tablet lang. Okay, so kalahati ng W2. So, that is 6 meters in length. Okay, so 6 meters. Okay, so consider natin yung ating members A, B, C. Okay. So we will sum up moment again about point C. Again, dahil pin tayo doon and moment natin dyan is 0. Okay, so na-eliminate natin yung mga unknowns dito sa may point C kasi meron tayong mga forces dito na sa connection nila. Okay, so again, summation of moment about point C is 0. So taking clockwise pa rin as positive. So from point C, okay, so yung RAY natin will produce clockwise moment, RAX natin will produce clockwise moment then. So unahin ko na muna yung unknown natin na RAX. Okay, so ano ang moment arm? So doon sa figure natin kanina that, so from point C papuntang vertical distance ng point C pababa doon is 7.5 meters. Okay, so again this is from this point sa taas. So this is 7.5 meters. Okay, so 7.5 meters. Then another clockwise moment yung RAY. clockwise done. So positive. RAY is 244.2 kilonewton multiplied by, so ito ngayon yung ating moment arm na 6 meters. Okay. And then we have counterclockwise moment about point C. Okay, dahil may force tayo dito. So, magpo-produce siya ng counterclockwise moment about point C. So, minus. So, W1 again is 14.4 kilonewton per meter. Yung length or span natin ng 5 meters. Then, moment arm natin from point C, vertical, kasi ito yung direction ng force na. So, ang kailangan natin is yung perpendicular distance, which is, this is 2.5, and this is 5 meters. Okay, it's 5 meters. Okay, then another counterclockwise moment. Ito, yung kalahati ng W2 natin. So, minus. Ang value ng W2 is 43.2 kilonewton per meter. Ang span natin ngayon dito is 6 meters to. Then, moment arm is kalahati ng 6 times 3 meters. And that is equal to 0. Okay? So, solve lang sa calculator. Transpose natin sa kabilang side. Then, everything will be divided by 7.5. So, ito ulit yung ating itatranspose. Then, divided by 7.5. Okay, so yung ating calculator. Unahin ko na yung mga negative natin na magiging positive sa kabilang side. 14.4 times 5 times 5 plus 43.2 times 6 times 3. Then magiging minus na ngayon yung 244.2 times 6. Okay. Then divided by 7.5. Okay, so nakuha natin ngayon is negative. Okay. So nag-negative 43.68. So RAX is negative 43.68 kilonewton. So again, if sabihin ng negative sign doon is opposite yung mali yung assumption natin. So hindi dito yung RAX. Instead, papunta siya dito sa may kanan. So yan yung RAX natin na equal to 43.68 kilonewton. Okay? 43.68 kilonewton. So, ngayon, ang kulang na lang natin is REX, which is nasa kabilang side ng structure natin, ng frame. So, consider natin ulit yung whole structure. So, lagay ko muna dito yung REY na 74.2 kilonewton. Then, ang assumption natin ng REX is pupunta din sa left side. Okay, so REX. Okay, then considering again yung whole structure natin, and we can now take the summation of forces along X. Then since we are in equilibrium, that will be equal to 0. So what are the forces along X direction? So first is yung RAX. Tayo doon sa kanan. RAX is 43.68 kilonewton plus yung ating W1, which is equal to 14.4 kilonewton per meter distributed. So we have to multiply this by the length, 5 meters. So yan. Then what else? Wala na, no? Then except dito sa REX, which is we assume na towards left or towards negative x, so minus REX, which is equal to, then all is equal to 0. So pag transpose natin to, so we can solve for REX. Okay, so ito yung transpose natin sa kabilang side, so para maging positive. So ito as is na siya. Okay, so let's compute. 43.68 plus 14.4 times 5. So we have 115.68 kilonewton. Okay, so nakompleto na natin yung ating reactions. So check natin if we obtain the same support reactions from StatPro. So again, REX natin is 115.68 kilonewton. Okay, so ito na yung ating StatPro. So reactions, yung dead load natin, okay. Kata muna natin yung ating load. So yung 14.4, papunta siya dun sa right side, and okay, 43.2 kilonewton per meter. So notice na PY yung direction na ginamit ko. Although yung load natin seems to be distributed along the length of the top cord or nung rafter, pero this is the same load nung dito sa given natin, no, na parang naka-apply siya sa horizontal projection, okay, which is 43.2 kilonewton per meter distributed along 12 meters span. Okay. So, ayan yung mga loading natin para sa dead load. So, na-run ko na yung analysis. Tingnan natin yung reactions natin. So, reactions ng dead load. Okay. So, ito makita natin. Okay. So, we have 43.68 kilonewton along X. Okay. So, papunta yun doon sa right side. Isipin na natin yung ating view. So, yung sinusunod dito ng StatPro is yung global directions natin. So, positive X, so papunta ron, papuntang kanan. So, same lang naman nung nakuha natin dito, no? So, papuntang kanan din. So, 43.68, RAY is 244.2. Then, we have negative 115.68, meaning papunta siya dito sa left side. Okay? Which is same lang na nakuha natin dito. Papuntang left side. Okay, then 274.2 kilonewton yung reaction natin sa Y. Okay? So, nakuha natin yung same result from StatPro. Okay, then next, para naman doon sa next requirement sa atin is draw shear, bending, and axial diagrams. Unahin na natin yung axial forces. Okay. So, we will solve this member by member. Okay. So, i-divide natin siya by member. So, para mas madali. Okay. So let's say yung ating member, hirap gumawa ng straight line. So assume na lang natin na straight line yan. Okay, so let's say this is yung ating member A and B. Okay, and meron tayong, so lagay lang natin yung mga load natin. Okay, then yung reactions kanina. Okay, so meron tayong reaction dito, which is equal to 43.68 kilonewton. Meron tayo reaction sa Y, which is I believe to 244.2. Okay, since kinat natin to dito sa joint natin sa point B, okay, so lalabas ngayon yung mga internal reactions natin. Okay, so obviously if the only force na acting vertically is yung 244.2, okay, then magkakaroon ngayon tayo dito ng force acting downward. Okay, so let's call this BY, and then yung BX natin, since puro pa kanan yung mga forces natin along X, so we expect na yung reaction natin sa point B is towards left. Okay, and since this is not a pin connection sa point B, so magkakaroon tayo ng moment. Then yung moment natin, so both itong W1 and itong 43.68 will produce, both will produce counterclockwise moment about point B. Then yung moment natin sa B, with respect dito sa member AB natin, will be clockwise naman. So this is moment. So lagyan ko na lang BA. So member B papuntang A. Kasi sa point B papuntang A, kasi sa kabilang member natin B naman siya pero papuntang C. Okay. So actual force, kukunin natin yung actual force muna. Okay, so yung actual force natin, vertically member natin, so all we have to do is take the summation of forces along Y. So equilibrium pa rin, equal to 0. So we have 244.2 kilonewton minus dy is 0, then dy is 244.2 kilonewton. Okay. So again, this force is, ito na mismo yung ating actual force. Kasi ano na siya, no? Mag-parallel naman siya dito sa ating member. Okay. So yun ay ating actual force, which is equal to By or yung ating Ray. Okay? So meaning, uniform yung ating actual load about this member AB. Kasi wala naman tayong ibang force within the length ng ating member. So uniform lang siya. So anyway, obviously, from point A to 44.2 kilonewton, so B hanggang point B, so we still have 244.2 kilonewton. So kahit saan tayo magkat dyan, so 244 0.2 kilonewton yung magiging internal resultant. Internal reaction rather. Okay, so uniform yung ating action load. So kunin naman natin yung shear. Shear naman tayo. Okay. So unahin natin yung shear sa point A. So from point A, mula dito sa may point na to, so yung only force acting doon sa point is yung ating yung reaction natin. No? Kumbaga kung ito yung ilalim ng let's say steel column man yan. Okay, so napakaliit lang, mas manipis pa dyan. Okay, mas manipis pa dito. Okay. So ito yung reaction natin sa ilalim. So may reaction tayo dito na 43.68 kilonewton. Okay. So yung uniformly distributed natin dito, very negligible pa yan kasi nga manipis na ito. So yung only force na i-consider natin is itong 43.68. So yung shear force sa A is equal to 43.68. Okay. So drawing ko lang muna to. Okay, then if for example mag-cut tayo dito, okay, so mag-cut tayo dyan. So ano-ano yung mga forces or shear forces acting about this point? Okay. So ano yung magpo-produce dyan ng shear? So that is 43.68. Then dadagdagan natin itong portion na to ng load natin. So hanggang makarating tayo doon. So yung shear force natin is linearly varying. Okay, so linearly varying, palaki ng palaki siya. Linearly again, hanggang makarating tayo sa point B. So para mas ma-visualize natin, tingnan natin dito sa may post-processing ito yung shear natin, Fy. Alisin ko muna itong bending. Okay. So nakuha natin kanina, shear natin sa point A is 43.68. So this member, ito yung ating starting point niyan. Shear force natin is Fy. So ito. So we have 43.68 na nag-i-increase hanggang makarating tayo doon sa dulo niya. Okay. Sa point B. Ito yung dulo niya, 244.2. So ito dapat yung makukuha natin. Action pa rin. Itong 115.68. Okay. So nag-increase siya. Linearly mata natin, straight naman yan. Okay. So solve natin. Okay. So shear sa point B. So ano yung mga forces, shear forces acting doon sa point B. So again, meron tayong 43.68 kilonewton plus, so habang palayo tayo doon, so padagdag yung force hanggang makating tayo sa point B. So ang nadagdag sa shear force natin is yung W1 na 14.4 kilonewton per meter times yung length natin na 5 meters. So yun lang. So yun lang yung ating shear force sa point B. Okay. Calculator natin. 43.68 plus 14.4 times 5. Oops, may mali ako. 43.68 plus 2.4 times 5. Yeah. So 115.68. monitor naman natin dito kasi kung at this point lang, itong pinakadulo lang, ang force acting dyan is itong bx natin. Solve na ba natin yun? So rex. So ito pala, so equal lang pala siya doon. Okay. So anyway, if we sum up forces then along x, okay, that will be still equal to 0. Equilibrium, hindi naman gumagalaw yung ating structure, so we are in equilibrium. So parang ganito rin yung solution natin, no? So if we sum up forces, so meron tayong rax, which is equal to 43.68 kilonewton, and plus itong W1 papuntang kanan din 14.4 kilonewton per meter times ng length na 5 meters. Okay, then ano pa yung force along x? Yung bx. So minus bx equals to 0, 5.68 kilonewton. So yun din yung makukuha natin. So, yun ang mismo yung ating shear force. Okay. So next yung ating moment. Okay. So member AB pa lang tayo, no? So yung moment natin, okay, so ang hinahanap natin is moment sa B. Wala tayong moment sa A. Wala naman tayong ibang given na lahat ng mga forces. Meron na itong value na 115.68 kilonewton. So again, hinahanap na natin is moment sa B. Okay. So if we take summation of moment about point B, equilibrium pa rin. So equal tayo sa 0. Okay. So take pa rin natin yung clockwise to be positive. Okay, so this is, so ano yung clockwise moment natin? Yung MBA. So yung moment sa B puntang A. So member BA lang. Okay. So para malinaw lang tayo sa member BA sa member BC mamaya. Okay. So yung moment sa B clockwise is positive. Then meron tayong W1 na magkakos ng negative moment. So minus W1 natin is again 14.4 kilonewton per meter. Span natin na 5 meters. Then nagmo-moment tayo sa B. Yung height natin na itong member na to is 5 meters. So uniformly distributed load, nasa gitna yung kanyang resultant. Okay, so times 2.5. So kalahati lang ng ating kalahati ng member. Okay? So, minus din itong RAX natin. So, sa point A, counterclockwise. So, 43.68 kilonewton times 5 meters yung perpendicular distance natin from point B. And that is equal to 0. So, pwede natin masolve yung moment sa B. Okay. So, calculator natin. Magiging positive na parehas, no? Pag tinranspose sa kabilang side. So, we have 14.4 times 5 times 2.5 plus 43.68 times 5 na moment arm. Okay, so we have 398.4 kilonewton meter. Okay, so tama ba yung nakuha natin? So balik tayo dito sa member A. Ang bending moment dito is yung MZ. Okay? So, itong MZ. So, 398.4. Okay? So, nakuha naman natin yung same result sa STAD Pro. Okay. So, ano itsura ng moment diagram natin? So, moment natin sa A is 0. Okay? So, kung ito lang, 43.8 lang, so, yung moment natin is increasing as the distance increases from the first na 43.68. So, sabihin, triangular or linear yung magiging moment diagram natin. Kung ito lang, 43.68. Okay? Pero kung meron tayong uniformly distributed load, then magiging parabolic na yung ano natin. So, second degree na yung curve ng ating moment diagram. Okay? So, makikita rin naman natin yun dito. Okay. So, yung ating MZ. So, makita natin na naka-curve yan, hindi lang masyadong naka-curve yan. Hindi naman siya straight and straight. Okay? So, pwede na siguro natin gawan ng force diagram, no? So, based dito sa mga result natin. Okay, so sa shear diagram natin, if compression is negative, okay, so let's say this is positive side, this is negative side. So, uniform lang ating, okay. So, again, ito yung ating member. Okay, pasensya na kayo sa drawing. So, yung ating actual load diagram is negative compression. Okay. So, rectangular po ito, no? Hindi ko lang makuha ang straight na straight. So, rectangular yan. Okay, then, dito naman, okay, yung ating shear diagram. Okay. So, meron tayong, so, if we consider this positive, then this is negative. So, kung titingnan natin dito sa portion na to, okay, so, yung shear force natin is acting towards negative side. Okay. So, this is, so let's say 43.68 kilonewton. So, parang di ba sa horizontal member natin, pag horizontal member kasi, kung ito yung load, so kung may load tayo dyan, uniformly distributed load, then yung reaction natin will be going upwards or positive kung pataas. So, kaya ang shear diagram natin dito, kung ganito, no, is pataas to, so positive yung ating shear. Then, meron tayong shear na pababa, shear forces na pababa. So, linearly varying ngayon to. Punta doon. Okay. Then, shear force ulit na pataas. So, magko-close tayo doon sa 0. Okay, so same lang dito, no? So, papunta siya yung load natin dito, sa side natin sa kanan. So, papunta rin dito yung ating shear force. Then, linearly varying. Okay. So, this is negative 5.68 kilonewton. Okay. So, paano naman yung moment diagram? So, again, actually, parang quadratic kasi yung equation natin doon. So, just to prove na parabolic yung curve natin. Okay. So, kasi if we take yung, let's say, meron tayong distance. So, kung about this point tayo nag-moment. So, let's say this is distance, distance y. Okay? So, yung ating moment ngayon about this point, okay, yung sa location na yan. So, yung moment natin will be equal to yung 43.68 times y. Okay, so this is linear, pero yung pangalawang magkakos ng moment, yung uniformly distributed load, is positive, this is negative, negative din tayo doon, counterclockwise. So this is, hindi ko nalagay yung value, W1, ano yung moment arm natin, Y, this is yung ano para to na, resultant load, okay. Total load, W1 times Y. Okay. Then yung resultant kasi nung portion na to is nasa gitna niya, so moment arm natin is Y over 2. So titignan natin, that is minus 1 half ng W1 Y squared. So quadratic na tayo dito. Okay? So, if we consider pa rin tong positive, then this is negative. Okay. So, ano ang moment natin? So, iba lang kasi yung moment diagram dito kay stud. Baka lang hindi tayo mag-match dito. Okay. So, going back muna dito sa portion na to. Paano natin ginagawa yung moment diagram niya? If yung shear force is nasa taas, okay. So, di ba yung ganitong uniformly distributed load? So, considering, halimbawa lang, fix yung magkabilang dulo natin. So, meron tayong moment dito. Meron tayong moment dito sa kabila. Okay. So, yung curvature ng beam natin is parang ganito. Okay. So, meron tayong negative moment. Okay. Negative moment sa may support. Then, kapag nasa taas yung shear diagram, yung area niyan is ina-add natin kung ano man yung value ng moment natin dito. Okay. So, since this is positive shear, yung moment natin is tumataas ngayon. Okay. Hanggang mag-peak tayo dito sa portion na to. So, nag-stop ka na magdagdag. So, nagsimula ka naman mag-subtract itong volume ng shear diagram. So, kaya magpipik na tayo dyan. So, then, eventually, unti-unti na tayo bababa. Okay. Then, clockwise moment. I-add mo nga yung clockwise moment. Then, magko-close tayo dapat doon. Okay. So, kapag naman pin support, so kung pin support naman tayo, wala tayong moment dito, wala tayong moment dun sa kabila, the moment natin at this point is 0. Then, okay, so habang since positive yung shear natin, nasa positive side yung shear, so ina-add natin yan. Okay, hanggang mag-peak tayo dun sa point na to. So, nag-stop ka na magdagdag, so hindi ka natataas. So, magsisimula ka na ngayon mag-subtract, meaning magsisimula ka ng bumaba dito sa moment diagram. Okay, so ganyan magiging itsura niya. So um, dito sa ano natin, dito sa moment diagram natin. So yung shear diagram natin kasi, so consider natin itong left side is positive, negative tayo dito sa right side, positive, then negative. Okay? So yung moment diagram natin dito is 0. Okay? 0 tayo dito. Then from 0 unti-unti tayo tumataas or parabolic yung curve natin. Okay. So yung ating moment diagram. So 0, then tayo doon sa taas. So meron tayong moment na 300, ano yung compute eh? 398.4. So kung titingnan natin dito sa may figure natin kanina, so kinat na natin to. So parang kung itong portion na to, gagawin natin itong naka-horizontal. Okay, so parang nandito yung ating let's say ito yung ating erase ko muna to. So let's say parang ito yung ating 43.68. Meron tayong uniformly distributed load ng 14.4 kilonewton per meter. Then meron tayong reaction dito sa B, internal result or reaction. So let's say ito yung A, ito yung point B. So ito yung 115.68. Okay? So na-figure, na-visualize na. So ito yun, ginawa lang natin naka-horizontal. So ito yung positive side, ito yung negative side. Okay. So moment natin dito is 0. Okay. Pero kung i-cut natin to somewhere here, okay, so bawa lang, no? Nag-cut tayo dyan. So etong portion na to, 43.68 and then yung 14.4 times this length, then again meron yung resultant dito. Okay. So magkakos yung dalawang forces na yan ng anong direction ng moment? Counterclockwise moment dito sa point na to. So kung ito yung ina-analyze natin, So yung dalawang force na ito sa left side, magkakos siya ng counterclockwise. So that's why consider natin tong negative. Okay? And by the way, yung shear force nga natin, ito, kung i-horizontal natin to, ang itsura ng shear force natin is ganito, no? Linear, straight line. So consider natin yung negative. Okay? So kung nasa negative ang shear diagram, so ganoon din yung ating moment. So from 0 moment, dahil pin support, so based dito sa shear diagram, so parabolic yung curve natin, second degree. Okay, so magiging negative 398.4. Then magko-close tayo dun sa taas dahil meron tayong moment dito sa B na clockwise. So kaya tataas to ng 398.4. So magko-close tayo dapat dun sa 0. Okay? So ito yung ating axial initial, share, and moment diagram para sa member AB. Okay, so i-continue ko yung solution sa next video na lang. Medyo mahaba na yung ating first video. Okay, so see you soon.